Um, so if this comes up for you, this will be an area we'll be coming back to for recurrent model access from AnyLogic's built-in models. AnyLogic does have an admirable number of built-in models, some of which Jeff and I have contributed to which Jeff and I have contributed. But for now, we're actually not going to be making use of this for the moment. So what I'd like you to do is I'd like you to go to this upper menu here, this little area here, and I'd like you to press on minimize, okay? And that will allow you to close off that window and come back to the site. So what we're seeing here is AnyLogic. It's a depiction of the basic interface for AnyLogic. What you will see in this interface is a set of areas of the screen which we'll be making heavy use of in the course of the week. Up here in the upper left, a projects area that can have one or more projects. Yes. Okay. Okay. So Dylan, what do they see?
So everything is just organized slightly differently.
Okay. Okay. So Dylan, the windows are in separate locations?
Yeah, so projects and palette are just two tabs on the left-hand corner.
So they look something like this.
Yeah.
Okay.
That's where and then their properties windows on the right-hand side, the default for AnyLogic.
It's over here, like that.
Yeah.
Okay. Okay. Thank you very much. AnyLogic modifies its defaults from time to time, and this user of AnyLogic modifies his defaults from time to time. So I'll try to stay in sync, and I'm grateful for you bringing this up. I have just illustrated a feature of AnyLogic that we may wish to take use of in the course of the week, which is the capacity to rearrange its interface. You can pick up and drag windows. You can choose which windows are in fact being shown here, and you can rearrange it so certain windows go together or are separate. Those of you who are inclined towards configuring your computers may wish to play around with them. But I'll try to keep mine in sync with yours for now. Okay? So you should see something like this. These tabs indicate availability of two different windows, one appearing behind the other. Okay? Okay. So having gotten into AnyLogic, we're going to be learning a lot about its operation, but it's much easier to sort of talk about after we get going with an actual example. So the next thing I'd like you to do, ladies and gentlemen, is to come down to this site, which we've had open, and I would like you to open up this thing that says example models, okay? Now, within the example models, I am going to, you should see something like this. This lists many different particular examples, okay? And I'd like you to open up a model that's, the full name is not clear, but it's called Introductory Teaching GDM model. And it's located on my screen down here in the second row, Introductory Teaching. If you open up that folder here by clicking on it, you should see a model like this, okay? A file like this. Now this is just Google Docs, how it displays things. We're not yet opening it with AnyLogic. Now, in a somewhat regrettable way, you do in Google Docs have to click on it and then click this download to download that model. Okay, let me do that again, just so you can follow it. So I just went in here to this site. I clicked on this place, Introductory Teaching. I clicked on this, and it showed me a most unpleasant site, at least for many. And then I pressed this download button up here to actually get the model onto my computer. It will actually now put it on my computer. It'll put it in my downloads area, okay? We're just trying to share models through the site, and I'm trying to show you how you get a model from the site into AnyLogic. So that's the first step. Does anyone have problems with that step? Because we'll be making use of that on a regular basis for sessions. It's worth kind of going through, making sure you're solid on it. So I apologize showing this to you, but this is just the way Google Docs works when you get certain types of files from it. Okay? I'll do it one more time. People make sure. I went into this example models possibly used in class. I clicked here, and then I went to download. Okay? And after you're done downloading it, after it's downloaded, you don't have to stay here. I did a back button so I can just be brought back to here. Okay. Anyone want a bit more time? Okay, you ready for the second step? You ready to go? Okay, great. Okay, so now, having done that, ladies and gentlemen, I'd like you to go back to your AnyLogic. We've gotten that file onto our computer. Great. Now we got to get that file into AnyLogic from that place in the computer to which it has gone, to whither it went. Okay. Okay, so I'd like you to do file in AnyLogic, file, open, and now and this will vary a little bit from computer to computer. Dylan, prepare for additional deployment. File, open, and you will point it to wherever your downloads are. On Windows, for example, I could point it to this downloads area. On a Mac, Mumble, I can't remember off the top of my head exactly where you point it, but you should be able to open it in a similar fashion. On my computer, it happens to be located a different area. And there's this model here which I downloaded. I actually showed it thrice, so I downloaded it 3 times, and I'm just going to open one of them. Okay, so I'm just going to open this up. I'm pointing AnyLogic to where to open this model I downloaded. Are people comfortable with that? Okay? Forgive me for going through this step by step, but we're going to be relying on this all through the 4 days. So it's very important that you're comfortable with this. So having opened this, you should see something along the lines of what's on the screen. Okay? Okay. Okay, so how many people would like a little bit more time to make this happen? Are people okay? How many people would like someone to come and help them with their computer? Okay? Okay, would you like a bit of help? Great. Dylan? Okay. Okay. Were you able to find it? Great. Okay. Anyone else need a bit of help? Bit of help? Okay. Okay. So, ladies and gentlemen, we have just loaded in and your first model here, and we are going to go and explore this model a little bit. This is a fairly articulated model, but it's not one that's particularly far beyond what we'll be building up in the course of this week. So I'd like to show you some features of it, okay? But first, I'd like to sort of browse through some aspects of the model. So if you double click on person, so over here in the projects area, if palettes is in front, you need to change it to projects. Okay. Okay, so this thing, yeah, it looks like this varies by browser. Okay, can you go back here? Okay, okay, then you go to that, okay. Okay, maybe, right, yes, this is a browser-specific issue here. Exactly, it's a browser-based. Okay, can you click on this guy? Sorry, this one. That one there, and then yeah, introductory teaching. Yeah. Okay, and then could you right-click on that instead of left-click? Please. You see, image as yeah. No, this is not okay. Let's do it. Click on it again, and that's what you want to click. That guy right there. then you save file. Yeah. You want save file. Okay. Okay, does anyone else need help to resync here? Okay. Okay, ladies and gentlemen, those who have this open, I would like you to double click on person here, and what you will see is something like the following. And I'm going to show you a feature of AnyLogic to which you may enjoy repeated recourse during the week. If you could double click on person here, you can see a broader, more expansive view. It will sort of zoom in to just that window. And double click on it again, we'll zoom out. But what we'll see here is a fairly visual representation of what I'll term informally a theory of personhood as far as this model is concerned. These models provide a way of putting under a single roof theory and evidence. Theory in the form of articulated understanding of, for example, the dynamics and information associated with a person, and some understanding of how that interacts with their context, their environment, on the one hand, and then it couples it with quantitative information, which may be drawn from a variety of sources of evidence. In this case, what we have is kind of a theory of personhood, in as much as it relates to their risk of developing diabetes during pregnancy and subsequently. So over here we see a set of characteristics of a person, such as their sex, their socioeconomic status index, their birth time, and the birth weight, and whether they were exposed to dysglycemic environment in utero. And here we have a woman, for a woman, there's a division between her being in a non-pregnant state and a pregnant state. And if she's in a pregnant state, does she have a pregnancy which is normal glycemic or dysglycemic? Further down, we have distinctions associated for that same person of a different sort. We classify them with respect to their weight status. For example, whether they are normal weight, overweight, or obese. And you'll notice that as above, there are these transitions that illustrate situations in which a person might move between these weight categories. For example, someone might gain overweight and fall within a BMI of 25 to 30 or into the range of obesity with a BMI greater than 30. Finally, on the right-hand side there's a distinction as to their diabetes status, whether they're normal glycemic, pre-diabetic, or of frank type 2 diabetes. And then up here on the upper right, we see a different sort of construct. We see a stock and flow depiction related to their physical activity over time that depicts how their physical activity is changing, particularly with respect to physical activity levels of people within their social network. So here we have a model where there's this cacophony of different things going on, but fundamentally what's being articulated here is kind of a theory of personhood with respect to this particular problem. And we'll see that in addition to kind of this logical information that we maintain, there's a visual depiction that will be used to show them visually as the model runs. I'd like, if you have zoomed in on this way to a particular view, I'd like you to double click on this again, and it will kind of zoom back, so allow you to navigate more elements of the model. And if you go up to main, for example, by double clicking on main, you'll see that there's information maintained about a population. Its size, for example, information about how to display people in the presentation. And further up yet, there's actually a set of graphs that will display certain information on people's evolution over time. But models like this, ladies and gentlemen, do not merely allow us to characterize a theory, to specify this theory. Critically, they serve as profoundly helpful learning prostheses, as Jeff has called them, or learning tools, by allowing us to ask, what are the logical consequences of this theory for behavior over time? So having articulated this theory involving personhood with respect to this model, be it a very stylized theory or a very articulated theory, we can then ask this model to do something that's very hard to do in our heads, ladies and gentlemen. To tell us the implications for behavior over time across the whole population of this theory of personhood, which is, after all, articulated, or which specifies not only individual behavior, but interactions between individuals. So in order to do that, within any logic, we make use of this, this area of the modeling project where we have these X's. The X, ladies and gentlemen, stands for experiment. And these represent different scenarios, different what-if questions. Scenarios that are associated with behavior over time. So I'd like you to go and I'd like you to right-click on baseline, and I'd like you to click runs. That comes up. Let me illustrate that again. Some of you may not have caught that, okay? Here I'm going to go and quick out of this for a second. I'm going to right-click just to show you how I did it and do run. And it will do some preparatory work, and then it will go back to the show me this screen here. And I will click run, and it will show me a set of individuals who are arranged in networks. Some of these individuals' network connections represent simple acquaintance or friendship. Others represent maternal links between a mother and her children. And what we see here is a depiction of this population over time at an individual level, where people's coloration and size is indicative of aspects of their weight status. You'll notice some of these growing as their girth enlarges. You'll notice that there's a depiction according to color here associated with their glycemic status, whether they have gestational or type 2 diabetes, for example. There's further this sort of red line that links up mother and children. There's also an illustration here in terms of growth associated with aging. So those with smaller ovals are comparatively younger people. You can pause this model up here. We'll be interacting with these models a lot. We can actually speed it up here or slow it down. But for now, ladies and gentlemen, okay, mine actually finished. It ran to its conclusion here. Some of yours might still be running, in which case you could press this pause button over here. Now, I'm going to show you some particular aspects of this model at different levels. So one thing is you can go to this menu here and you can pull down, it will say population, 0 to 468. This allows us to cycle through different people in the population, what their specific characteristics are. For example, here's a person who at the start of the model, at time 0, was 21.5 years old. They had a birth weight in kilograms of nearly 3250 grams. They're female, and they have a rather low SES index here. Now, some of these features affect their physical activity level, which is currently shown at the end of the simulation as being this, but which evolved over time according to the physical activity levels of some of their surrounds. How did I get that? I clicked here, just a simple click, and then I use this little graph functionality here. And it shows the evolution of their physical activity over time. Other aspects of their status is also shown. For example, right now they're obese, but they have remained normal glycemic at this point. Okay, we could go look at another person, person 1, who's a male, comparatively high income, has a higher physical activity level, had a lower birth weight associated with them, and were not exposed in utero, etc. This male is bereft of children. we do maintain information on the parent-child relationships. So this is a model that we're browsing through as it runs, or having finished run here, and we can go down to the level of each person, and we can inspect sort of the characteristics of that person. What's their current characteristics? You notice the person's visual depiction is shown here in the upper left. People are in different states. And that's of interest. After all, we can go down and understand information about the biography of a person. For example, their evolution over time, how the weight status of this particular person changed over time. But we can do more than that with these models. That longitudinal lens of particular individuals is profoundly valuable, particularly if you have access to administrative data or data from a cohort that you've been following. You could try to match it to this sort of information. But we're not limited to that individual level view, as valuable as that is. Let's go here and let's press this up to get back to this population. And let us now right-click and scroll down here. Now, Dylan, on a Mac, right-click is what, option click? Oh, it's two-fingered salute. Okay.
Yeah, you might be able to do it that way. I think that's the easiest way.
Okay, with two fingers, use that to click simultaneously, Dylan? Or to drag with the right button pressed down? Okay.
Two fingers and then push down onto the pad.
Two fingers, you should be able to drag it down. Okay, are people able to see this? Are people able to drag this up? Okay. Okay, Dylan, there's, okay. So what happens when you try to do that? So I'm on a PC, I'm doing right click. Okay. Okay, who needs help here to scroll up and see this area of the screen? Can you see this? Okay. Who would like Nolian help? Dylan Knowles is a resource to be contended with. Who else would like help here? Okay. Okay, so ladies and gentlemen, up here what we see is summary measures computed across the population, perhaps for different subsets of the population. For example, high SES and low SES individual, looking at the prevalence of diabetes in each of those groups compared to the crude prevalence for the population as a whole. We can classify the population by whether they're exposed in utero or not, and look at the differential impact on prevalence of diabetes there. We can, on the other hand, also break things down by age, by sex, and other components. Here, we can look at aspects of an individual's history. For example, the number of gestational diabetic episodes encountered by a woman amongst high SES and low SES individuals, or the number of years that individuals spent obese over the course of their time to this point among the high SES and low SES individuals. We can look at profiles of physical activity for those with and without diabetes, and note that they're somewhat lower amongst those with diabetes. And then finally, scrolling over yet more, we can look at aspects that are implied by the model at the level of broad patterns between individuals. So here we see three plots, which are scatter plots. Each dot within these plots indicates a particular individual in the population. So this plot here on the lower left, we have SES index on the x-axis and physical activity on the y-axis. And what we'll see is a general rising trend, not without the exception, but a general rising trend as individuals have higher levels of socioeconomic status. They have somewhat higher levels of physical activity within this model. Up here we see SES index, again on the x-axis, but cumulative years obese. And we see quite a bit of variability, but more individuals as SES rises whose levels of obesity cumulatively are zero, and they crowd down here on the y-axis. And here birth weight versus age at which a person developed diabetes. So here we have summary measures across the entire population, which sort of allow us to compare the population trajectories over time, as well as measures that capture aspects of individual history and show patterns. Now, these patterns that we see, ladies and gentlemen, these rising rates, for example, here of SES index versus physical activity or versus cumulative years obese, these profiles associated with years with physical activity or with years diabetic, these were not things we directly put into the model. We didn't tell the model to impose a draw from a certain distribution for physical activity for diabetics versus not. Rather, these were emergent features of the system. These were produced by running this model as a logical consequence for what we told it to do, but without having any pre-specified instructions at this sort of level. This results from, this is both a symptom of, and in some cases it is a driver for, further behavior in the model, but it is not something that we pre-programmed into the model. Similarly, these rates over here we saw earlier on with rising levels of diabetes, with rising exposure to dysglycemia in utero, etc. These are things that result from the model that reflect an interaction, an entangling of many different components of this model, but aren't directly put in by us. The model is generating these patterns from the logical consequences of our assumptions. Now, you could say at some level that our model implied these patterns, at least once you take it together with its specifics in terms of the data assumptions. But these were patterns that we couldn't have recognized by sitting back in our chairs and merely reasoning about it, because even the most quantitative of us will be stymied by the multiple implications of these features. So models like this help us to reason about the logical consequences of our assumptions. Consequences in terms of the behavior of this system over time, but also critically in terms of consequences for interventions that we may try to leverage to improve the health status of the population. So to see that, I'd like to go beyond the baseline here, and I'd like to take a look at some additional alternatives, ladies and gentlemen. Specifically, I'd like to take a look at some of these alternatives shown here, and that we will be having over here in the lower part. So to do this, I really should have been careful. Maybe what we'll do is just one more time, I'd like to run this, and I'd like to count up some features with the baseline, and then we'll see how those are changed for these interventions. So I'd like to run the baseline one more time. My apologies, I should have drawn your attention to it earlier. We'll speed it up full steam. We can do so with this button here. It says toggle virtual and real-time mode. So we're going to run this out, and we're going to let this run for 100 years. And you'll notice that as the population evolves, individuals are interacting, networks are formed and broken, babies are born, babies grow up, and the model proceeds accordingly. This model, as a dynamic model, starts in some initial state, and then it runs step by step by step over time. In this case, actually in continuous time. It runs, things happen as fast as they need to in order to capture the features of the situation. And you can see here there's actually a calendar in AnyLogic associated with the running of the model, whereby we could actually ask for more details about particular days, recent, in some models about aspects of the work schedule, holidays, etc. Okay, so we're running this up to time 50, and having done that, I'd like to go look at one particular graph that counts the number of cases of diabetes on the one hand and gestational diabetes on the other, okay? So if we scroll down here, here we have accrued prevalence of diabetes, and over here, cumulative cases of diabetes and of GDM, okay? And you can see the cumulative cases of GDM in mine went up to about 30 here, and cumulative cases of diabetes went up to about 50 for this baseline case. Is that somewhat similar to what you folks are seeing? Okay. I would like you now, having done that, we could obviously accumulate information here. You could copy this graph and paste it in as a set of data if those would interest you. But for now, we'll leave that behind, and we'll run some of these alternative scenarios. So one of the most powerful uses of this model, and perhaps the foremost use by which they're sought, is the ability to look at counterfactuals, to ask what-if questions about situations which haven't been previously experienced and on which data is therefore absent, where we can't run a statistical analysis because we've never seen that situation before. And in this case, what we're going to do is we're going to look at a case where we enhance physical activity here by different levels across the population, okay? So I'd like to take a look at enhancing it here by 20% across the population. So I click on this experiment here, and I'm going to do run by right-clicking on it and choosing run here, okay? Here we go, and here it's going to run. Let me just make sure that we're hunky-dory as far as the video is concerned. Okay, and again, I'm going to run this as quickly as possible. So what I've done here is to put in an assumption that we're going to seek to elevate the initial levels of physical activity within this model by a certain amount. So we'll tend to make people have somewhat higher levels of physical activity at the start. And that will have effects for those people, but also for their social networks in terms of patterning, in terms of imitative behavior, in terms of their children, for example, where the patterning might be particularly strong. So running this model out, we will see, again, the progression of these assumptions, which are altered from the baseline. They're alternative assumptions. We're asking what if for a situation that's different from the baseline, okay? Running this out here, what we're going to see is for 50 years, we'll see that we again have some experience in terms of cumulative cases of diabetes here and cumulative cases of gestational diabetes. For cumulative cases of diabetes, we haven't seen in this case a large difference, but we have seen cumulative cases of gestational diabetes here, which are now below 30, where it's been somewhat lowered. And the change in cumulative cases of diabetes, we've also seen some decrease, I believe. I should have had better notes on the original value. It's a little bit different from my notes here, but I believe there may have been some decrease. So let's stop that, and then let's go down to another one. Let's say we increase it by 40% across the population, not 20%. So we're going to go down and run that scenario. And once again, we will run this forward for 50 years, okay? With these altered assumptions concerning levels of physical activity at the start of the model, okay? So we're running it forward now. Once again, we have populations of individuals born, interacting, engaging in imitative behavior, individuals whose behavior is somewhat affected by their SES status, but also by those around them. Their evolution is evolving according to multiple lines of evolution for particular individuals. Here, for example, was a normal weight individual who had been, who was also normal glycemic. Okay, now it's an obese individual, normal glycemic. And we'll go back up to this level here, and the model will be finishing up here. We see a lot of family structures here, really playing a prominent role. Okay, so having run that, we'll go up and we'll take a look at that same graph. And here we are. Here's cumulative cases of diabetes. And now we've brought down significantly the cases of diabetes. The case of GDM, well, there's some statistical variability, it looks like. That one hasn't decreased that noticeably. And finally, we'll go back for the cross-population measures and look at a more dramatic increase in physical activity. You note, at the moment, we are putting aside the question of how we'll achieve that. That will be the subject of later discussions. We'll be taking a look at the implementation science side of things, as well as the side from a cost-effectiveness standpoint of how much it takes to support it. I'm right now running the case of 80% increase in physical activity within the model. And once again, we're having a situation where the model is running out to show us the logical consequences of how things add up in a way we wouldn't be able to compute within our heads alone. In a way, we have all these entangled different components that we've captured in sort of that theory of personhood, and they're all interacting to shape the health of the entire population. Okay, so with that coming to a close here, I'm going to go up and go take a look at the consequences here. We're closing in on our final times, and once we still do see an upwards increase associated with the levels of both GDM and of frank type 2 diabetes, but we see somewhat lower levels associated with each in this case. In a final case, we might, for example, examine the impact of confining our analysis to only pregnant women, to examine the impact of enhancing physical activity during pregnancy for that particular subgroup. And here we'll look at enhancing it among reproductive age women versus among pregnant women. I'm just going to run the first of those, the pregnant women. And here we have an intervention going on. It's a much more targeted intervention, one that focuses on that period of pregnancy during which women are often quite motivated to make a difference, but also during which many risk factors can appear in the form of gestational diabetes that might predispose a woman to develop later cases of type 2 diabetes. So we're running this out. In this case, there's only interventions going on at the level of pregnant women themselves, and we'll see the consequence of that specifically targeted intervention. So as this is proceeding, I will go up here and take a look at the cases of gestational and type 2 diabetes that result from these assumptions. Okay, so in all of these cases, we'll go into how this model works in a later session, but in all these cases, we're altering our assumptions. We're asking the model to compute what if. What if we could accomplish one change? What if we could accomplish another? What's the implications according to the burdens that we see across the entire population? And we can compute this in a way that allows us to ask, okay, how much have we really gained? Now, the way we're accomplishing it here is a little bit ham-fisted. In general, we will want to run a model many, many times because of stochastics associated with the model, vagaries in terms of the model the model assumptions in terms of the social networks, or whether a given mother develops gestational diabetes or not in the course of a pregnancy, which may have long-standing implications. But in general, we can take a look at the outcome of one set of scenarios, preferably over many, many runs, and compare it to the outcome of other scenarios. And by so doing, we can ask these questions, these what-if questions that are really hard to probe because they're counterfactual. They're hard to probe using statistical techniques, using techniques which rely on existing data. So we've taken a model here. The model has captured some fairly articulated theory. In this case, it's a toy model, a model that was built up for demonstrations. But it reflects a very detailed research program we do have going on with several simulation models in the gestational diabetes area. We populate it with some data about the population. We'll go to Maine here, double-click on Maine, and we'll scroll down and see some aspects of the population that we've assumed. So if you double-click on Maine and you scroll down to this area that says population, you can go and you can see that, for example, we're drawing characteristics of an individual from probability distributions. For example, the population is uniformly distributed at time 0 between 0 and 80 years old. The sex is determined with equal likelihood. The SES index is dependent in its computation for whether we wish to impose disparities. If so, we'll draw from a broad distribution, otherwise an extremely tight one. We can set birth weight in grams by drawing from a distribution here, etc. So behind this model, behind that population, behind that cacophony of different interactions, were some data, data in the form of probability distributions, data in the form of empirical information from a population, perhaps, in the form of the population demographic distribution, and those things are encoded within this model. We can then, by running the model, by simulating it over time, we simulate the evolution of that population, we see the consequences. Consequences either for some baseline reference case or for some counterfactual cases which might characterize situations which we're interested in exploring, but on which empirical data is lacking or is poor or is completely non-existent. So in this case, we're using a model to serve as a thinking tool to help us make sense of the implications of our theory, of a possible theory about the world and of the data that we have, to make better use of that data. Models like this, ladies and gentlemen, help us more quickly spot inconsistencies between our theories of the world and the empirical data. They're not an alternative to data. They don't eliminate the very key need to collect data and to refine our sense of data quality by using best practices. But they help us spot inconsistencies between what we think might be going on out there in the world, as captured, say, by this sort of theory, and what we actually observe in the data. These models don't tell us what is the case in the world, but they help us more quickly rule out what is not the case, separate the wheat from the chaff, by helping us total up the consequences in terms of other things that we wouldn't be able to figure out in our head, in terms of their consequences for what we would expect to see from the data, for example, about levels of gestational diabetes amongst different population subgroups, in ways that are not programmed into the model, but rather result from the model. So these models help us think through more clearly, rigorously, quickly, and reliably the consequences of our theories in terms of what they should mean about the world. They help us spot inconsistencies between our theories and what we observe in the world, and help us ask what-if questions about situations which have never been observed before in the world that are more likely to be robust than if we tried to arrive at understanding purely in our head or purely based on historic data. So this is a glimpse of a model. Any questions about this model before we go into some of the theory behind it? Any questions? I know you've seen a lot. It's what William James once called the buzzing, blooming confusion. There's a lot there, a lot of questions, a lot of uncertainties, and that's one of the best ways to bring out questions, bring out puzzles that can then be addressed in subsequent presentations. This boot camp is not a spectator sport. This is an event where it's very important that you be actively engaged, and by showing a model up front, it will get you wondering about particular features that hopefully I'm able to address in the subsequent sessions. But are there any questions I could address right now before we take a bio break and then continue on with a glimpse of theory? Question back there? Yeah.
I'm sort of wondering how many of those charts and displays were preset by the model builder and how many are developed by the system itself?
Great question. So all of those charts that you saw, the content of those charts, what was the x-axis, what was the y-axis, what were the scales associated with those axes, etc., are things that are typically built by the modeler. Sometimes you choose for the system to set the scale, for example, but other times you say, I want this scale between 0 and 1 for SES index, or what have you. For the most part, those things are specified by the modeling team, and by extension by the modeler, and putting them into place as part of the model. The system doesn't automatically have a sense of which measures or metrics are likely to be of greatest insight to your particular area. And as a result, it provides, and if we go to this palette area, we could actually go see this. It provides, if you go to palette and you go down to this area called analysis here, what you'll see what it provides. It provides a capacity for recording information as the model runs, and these things called data sets or histogram data. And it provides charts to plot that sort of information out. Bar charts, stack plot, time plots, scatter plots, histograms that serve as useful measures, or as sort of useful constructs for displaying measures. But the choice of what you want to display and exactly in what way you want to display it, that is a decision made by the modeling team and modeler, not by the software. The software is ignorant of the implications of epidemiological theory and what you should be looking at, what charts are meaningful, what charts of interest. And so it just provides you kind of a vessel with which to specify the charts you want. And if you want to go see how that's done, and I welcome these questions, go up to main. So go back to project, double click on main. We're learning some basic skills here to navigate these models. If you go, having double clicked on main, if you scroll up, for example, let's take a look at this chart here in the lower left. If we click on that, you'll notice that something went on within your properties window. And I'll sort of draw this over here. Here, I told this chart, as part of building this model, I think it was late one night before boot camp. I think it was maybe the Adelaide boot camp, actually. I specified here, okay, the first thing I'd like to display is the crude prevalence of diabetes, and I'd like it to display that. I'd also like it to display the prevalence of diabetes among low income, and I told it use this statistic to do that. And that statistic there is something that I defined as part of this model. And all of this are things that we will be learning to deploy before the sun sets today, okay? For many aspects of this, and certainly before the boot camp is out, you will be very familiar, perhaps for some of you too familiar, with elements of this. Are those comments helpful?
Yes, I asked but I thought I heard you say that none of those graphs were pre-specified.
They're not, okay, what I mean by that is, okay, so I'm trying to remember my jet-lagged utterances here, but I think what if I did use those words, it was probably to refer to the fact that on a model-by-model basis, we'll have different graphs in place, and the choice of what we wish to display within the graphs will be contingent on the model focus. So if I had a model focused on even something related, say diabetes to end-stage renal disease progression, I might show a Kaplan-Meier survival curve. If I were interested in the spread of a communicable illness, I might look at the epi curve associated with number of cases on a per week basis of this notifiable illness. That would be a construct that would be useful for that context. In other cases, I might look at a histogram or a plot that gives me insights into disparities. I might look at a graph of the Gini coefficient if I was really interested in aspects of health disparities, in their relation to income disparities. So what's in these charts? These charts are provided in the sense that you provide the mechanism for specifying a chart really easily, but what goes in that chart, what goes in the x and the y axis, what particular data is plotted, that is something that is determined on a model-by-model basis, and that is something that you will determine many times in the course of this boot camp. Okay. Other questions? Okay. So, ladies and gentlemen, should we enjoy a health break and reconvene here in perhaps 10 minutes, and then we'll dive in to some of the meaty conceptual issues that underlie these models and some of the aspects of their relation to other models that you will have seen. Is that okay? Okay, very good.